This is how the cover page of mathematics paper 1 looks like. Here is the subject code 0770 math with statistic 1. Mobile phones are not allowed in the examination room. Multiple choice question paper 1.5 hours. Instructions to candidates. Read the following instructions carefully before you start answering the questions in this paper. Make sure you have a soft HB pencil and an eraser for this examination. 1. Use a soft HB pencil throughout the examination. 2. Do not open this booklet until you are told to do so. Before the examination begins, check that this questions booklet is headed Advanced Level 0770 Maths with Statistic 1. This is the same for Maths with Mechanics 1. Fill the information required in the spaces above. That is candidate's name, exam session, subject code, and candidate identification number. Take care that you do not create or fold the answer sheet or make any marks on it other than those asked for in this instruction. How to answer the question in this examination. Answer all questions in this examination. All questions carry equal marks. Mathematical tables and calculators are allowed. Each question has 4 suggested answers, A, B, C, and D. Decide on which answer is correct. Find the number of the question on the answer sheet and draw a horizontal line across the letter to join the square bracket for the answer you have chosen. For example, if C is your correct answer, mark C as shown below. Mark only one answer for each question. If you mark more than one answer, you will score a 0 for that question. If you change your mind about an answer, erase the first mark carefully, then mark your new answer. Avoid spending too much time on any one question. If you find a question difficult, move on to the next question. You can come back to this question later. Do all rough work in this booklet using the blank spaces in the question booklet. At the end of the examination, the invigilator shall collect the answer sheet first and then the question booklet. Do not attempt to leave the examination hall with it. You have to take note here that this paper is Maths with Statistics 1, 2018. This paper is not much different from Maths Mechanics 1, 2018. The difference is just in the section B. Section A of paper 1 is pure mathematics. Section A is the same for math statistics and maths mechanics. Section B is only on math statistics. The same for maths mechanics paper 1. Section B is only for maths mechanics. Section B is usually around 15 to 10 questions, while section A is usually around 35 to 40 questions. The total number of questions in section A are 50, and you are required to answer these 50 questions in 1 hour 30 minutes. So it means one question is approximately 2 minutes. Thus, if you spend more than 2 minutes in one question without being able to come out with the right answer, it's better to go to the next, because you will not be able to have time to answer the others. For section A, at the moment, I'll answer the first 5 questions. Then for the next video, I am going to answer the other remaining questions. Question 1. Given that x over 3 minus x into 4 minus x is equivalent to p over 3 minus x plus q over 4 minus x. A. P is equals to 3, q is equals to 4. B. P is equals to 4, q is equals to minus 3. D. P is equals to minus 3, q is equals to minus 4. This is a partial fraction with repeated linear factors in the denominator. And normally, it is always expressed like this. So to get the value of P and Q, we need to look for the LCM of the right hand side. That is x over 3 minus x into 4 minus x is equivalent to P over 3 minus x plus Q over 4 minus x. The LCM here is 3 minus x times 4 minus x. 3 minus x cancel here. I'm going to left with 4 minus x. 4 minus x times p is p into 4 minus x. 4 minus x cancel here. I'm left with 3 minus x. 3 minus x times q is the same like q into 3 minus x. Now this fraction is equivalent to this. So I've expressed this fraction in this form. It means this fraction is also equivalent to this one. That is x is equals to p into 4 minus x plus q into 3 minus x. To get either the value of p or q, I need to look for a value of x that when I substitute in any of these terms is going to eliminate either q or p. That is the substitution method. Now if I let x equals to 4, that means I'm going to have 4 in the place of x is the same like p into 4 minus 4 plus q into 3 minus 4. 4 minus 4 is 0. 0 times p is 0. So I am going to have 4 is equals to 0p plus minus 1 times q. You know 0 times p is 0. So it means minus q, which is minus 1 times q, is minus q is equals to 4. It means q is equals to negative 4 if I divide both sides by minus 1. So the right value of q is minus 4. Now if I let x to be equals to 3 and I substitute in this equation, I'm going to have 3 is equals to p into 4 minus 3 plus q into 3 minus 3. So I put 3 in the place of x. Anyway, I see x. Here I'll have 3 is equals to p, which is 1 times p, because 4 minus 3 is 1. 1 times p is p plus 0 times q. That's 3 minus 3 is 0. I have 0 times q. Now 0 times q is 0. So it means I'm going to have 3 is equals to p plus 0. It means p is equals to 3. Now we've gotten p is equals to 3 and q is equals to negative 4. From the options given, the right option is C. I have 2 channels in YouTube where I give out free maths videos to everyone. Bond maths classes and bond maths revision. In bond maths classes, I teach the theory. In bond maths revision, I solve past questions in the GCE. Let's say if you watch a video in bond maths revision and you didn't understand the solution, you can come to bond maths classes. You will see the topic related to that solution with explained concepts and solved examples. To be able to continue to see new videos from any of these my channels, you need to subscribe to the channel and like any video that you see. Subscription is free. To subscribe, you come down to this subscribe icon and you click. When you see subscribe, it means you have already subscribed. And then to like, you come to this thumb icon, you click. If you see the number changes, it means you have liked. Sometimes you may want to subscribe, they ask you to log in. Yes, you need to log in to YouTube using your Gmail. To log in is free and to create a Gmail is free. Number 2, the roots of the quadratic equation 2x squared minus 3x minus 1 is equals to 0 are A. Real and equal, real and distinct, imaginary, both negative. You have to know the quadratic equation is an equation of the form ax squared plus bx plus c is equals to 0. I know a quadratic formula is given by x is equals to negative b plus minus square root of b squared minus 4ac all on 2a. This expression under the square root is always called the discriminant. That is, discriminant d is always equals to b squared minus 4ac. If the discriminant is equals to 0, then the roots will be real and equal. If the discriminant is less than 0, then the roots will be imaginary. Now, if the discriminant is greater than 0, then the roots of the quadratic equation will be real and distinct. These are the three conditions from which the roots of the equation can be determined using the discriminant. Now, our quadratic equation is given by 2x squared minus 3x minus 1 equals to 0. We need to verify the following conditions. If I compare this to the general quadratic equation, it means a is equals to 2, b is equals to minus 3, c is equals to minus 1. Discriminant is equals to b squared, which is minus 3 all squared minus 4ac. A is 2, c is minus 1, which is equals to 9 minus 4 times 2 is 8. 8 times minus 1 is minus 8. Minus times minus is plus, so it will be 9 plus 8, which is equals to 17. It means the discriminant is greater than 0, since 17 is greater than 0. And if the discriminant is greater than 0, it means the roots are real and distinct. So the right option here is B, real and distinct. Number 3, a relation R is defined on the set Z of integers by xry or x relate y if and only if x plus y is greater than or equals to 5. R is A, reflexive, B, symmetric, C, transitive, D, an equivalence relation. Now we know that for every xy belonging to the set of integers, x relates y only if x plus y is greater than or equals to 5. The set of integers is the set of negative and positive whole numbers. That is, z is equals to the set in which we have positive numbers to the right, that's 1, 2, and so many others here, and the negative numbers to the left, that's minus 1, minus 2. I can list as many as possible. So it's a set of positive whole numbers and negative whole numbers. A, they're asking if the relation R is reflexive or symmetric, transitive, or is an equivalent relation. If we are given any set, let's say A relation R in the set A is said to be reflexive if, that's for all elements A belonging to the set A relates A, then the relation R is reflexive. Now, if for any two elements in A, let's say A, B belongs to A, whenever A relates B and the B relates A, then the relation R is symmetric. That is, if A relates B, then B relates A, the relation is symmetric. Now, transitive. For every three elements, let's say A, B, C belongs to the set A, whenever A relates B and B relates C, it means A should relate C. In this case, we say the relation is transitive. A relation is an equivalent relation if it is reflexive, symmetric, and transitive. 2 belongs to the set of integers. 2 plus 2 is equals to 4, which is instead less than 5. That means 2 do not relate 2. But for reflexive, for every element found in the set A, if A relates A, it means the relation is reflexive. Now, we've seen 2 in the set of Z. 2 do not relate 2, since 2 plus 2 is not greater than or equals to 5. It means this relation is not reflexive. 3 and 5 belongs to the set of integers. 3 plus 5 is equals to 8, and 8 is greater than or equals to 5. It means 3 relates 5. The same as 5 plus 3 is equals to 8, which is also greater than or equals to 5. It means 5 relates 3. Symmetric means that for any two elements in the set A, if A relates B, then B must relate A. So we have taken two elements in the set Z. 3 relates 5. Now we've seen that 5 also relates 3. It means this relation is symmetric. 2, 5, and 1 belongs to the set of integers. 2 relates 5. Since 2 plus 5 is equals to 7, which is greater than or equals to 5. 5 relates 1. Since 5 plus 1 is equals to 6, which is greater than or equals to 5. From the transitive property, if A relates B and B relates C, then A must relate C. So since 2 relates 5 and 5 relates 1, it means 2 must relate 1. But 2 do not relate 1. Since 2 plus 1 is equals to 3 and 3 is instead less than 5, the condition was that it should be instead greater than or equals to 5. Hence, this relation is not transitive. Not transitive. That means the relation is instead symmetric. The right option cannot be D. Since D is an equivalence relation, and an equivalent relation is that which is reflexive, symmetric, and transitive. We have already seen that the relation is not reflexive. It's not also transitive. Number 4. Given the polynomial p of x, where p of x is equals to ax squared plus 5x squared plus 2x is ax cubed, is divided by x minus 1. The remainder is 4. The values of the constant a is a minus 17 on 7, b 3, c minus 3, d minus 18 on 7. From the factor and remainder theorem in polynomials, if we are given a polynomial, say f of x, and a factor, say x minus a, if f of x is divisible by x minus a, it means f of a should be equals to 0. If f of x divided by x minus a and the remainder is say d, it means f of a should be equals to d. They say this polynomial divided by x minus 1, the remainder was 4. So what is the value of a? That means from the factor and remainder theorem, p of 1 is equals to 4. That means a into 1 cubed plus 5 into 1 squared plus 2 into 1 is equals to 4. 1 cube is 1, so here I have a plus 5 times 1 is 5 plus 2 is equals to 4. That is a plus 7 is equals to 4. A is equals to 4 minus 7, which is equals to minus 3. So the right option here is C. Number 5. The value of half log root 8 base 2 is A 4 on 3, B 1 quarter, C 3 on 2, D 3 on 4. You know, from indices, root a n is the same like a to the 1 on n. It means root a is the same like a to the 1 on 2. You also have to know that from logarithm, log a base a, let's say to the b, is equals to b. You also have to know that log b, let's say base a to the n, is the same like n log b base a. That means root 8 is the same like 8 to the half power, which is the same like 2 to the third power to the half power, which is the same like 2 to the 3 on 2. You also have to know that from indices, a to the n times m is the same like a to the n m. That's a to the n times n. That's the same thing here. 2 to the third times to the half is the same like 3 times 1 over 2, which is 3 over 2. That means half log root 8 base 2 is the same like log root 8 base 2 all to the power half. From this property, that's n log b base a is the same like log b to the n. So I bring this half to this place, but I know root 8 is the same like 2 to the 3 over 2. That is log 2 to the 3 over 2 all to the power half base 2. 2 to the 3 over 2 all to the power half is the same like multiplying 3 over 2 to the power half from this law of indices. That's n times m. 3 over 2 times half is the same like 3 on 4. That's 2 times 2 is 4. So it means this is the same like log base 2, 2 to the 3 over 4, which is equals to 3 over 4. Since the base here is a and we have a here, so the log will be the power here. As the case here, 2 here, 2, and then we take the power, which is 3 over 4. So the right answer is D, 3 over 4.